Hello everyone, I am Kavya from National Engineering College, Kovilpatti. I am currently pursuing BE Electronics and Communication Engineering. I am here to explain about embedded system which I have learned during my internship period, which was offered by Emertex, and I am going to explain about how to implement an automatic washing machine by using PICSIMLAB. So let's see one by one in this presentation. So these are the topics I have learned during the internship, like introduction to C language, and then conditional statements like if-else statements, and then loops, while loops and do-while loops, and then arrays and pointers, and introduction to embedded system, and some of the softwares like MPLab, XIDE, and then PICSIMLAB and XC8 compiler. So these are the data types in C language. Basically, data types can be classified into three types, like a primitive type and derived type and user defined type. So primitive type is nothing but the basic data types, which includes characters, which is used to store the single characters like alphabets and including special characters. So next, integer data type, which is used to store the real numbers including positive and negative numbers, and then float data type, which is used to store the decimal numbers with a single precision, and then double data type, which is also used to store the decimal numbers but with double precision, and then wide data type, which is used to specify the no values, that is it has no values and no operations. And then next, derived type, it can be divided into three types like signed, unsigned and long tuple. So signed data types, which is used to store the negative numbers, which include signed character type, signed short type, and signed integer type, and signed long type. And then next, unsigned data type, which is used to store only positive numbers. So it is also can be divided into unsigned characters and unsigned short type and unsigned integer data type and unsigned long type. So next, user defined type, which includes array data type, struct data type, and then union, and then enum data type. So enum data type is used to specify the name into some constant values. Okay, these are the data types in C. So next we are going to see about the embedded system. Basically, an embedded system is a combination of computer hardware and software designed for a specific function. So there are three main components of embedded systems, like hardware, software and firmware. So hardware is nothing but which is used to specify the physical components that are physical peripherals in the embedded systems, like microprocessors and microcontrollers, memory, etc. Next, software. So software which is used to control the behavior of the embedded system. So there are so many languages like C, C++, Python. So next, firmware. Firmware is also a software, but it is a subset of software which is mainly used to program a physical components of embedded system. Next, the types of embedded system. There are four types of embedded systems, like real-time embedded systems, and then sandbox embedded systems, and then network embedded systems, and then mobile embedded systems. So real-time embedded system, which will execute the operation within the deadline. For example, missile embedded systems, and then standalone embedded system, which can take the decision on its own. So Tesla car, it's the best example of standalone embedded systems. And then network embedded system. It can easily connect with other devices and it can transmit and receive the data. So next, mobile embedded system. It can be easily carried from one place to another. So these are the some of the types of embedded system. And then here some of the basic components of embedded systems, like a power supply, microcontroller, memory. In memory there are ROM, RAM, and then EEPROM. So like this, and then timer or counter, and then communication port, like a serial communication port. Under the serial communication port there is a UART protocol. So and then input or output. Okay, now these are the some of the examples of embedded systems. Basically, embedded systems is used in various fields, like in domestic appliances, micro oven and washing machine is one of the examples of domestic appliances, and then audio visual equipment and gaming controllers, then telecommunication equipment, then even it is used in medical devices, and then car and vehicles, and then motion sensors, and then manufacturing equipment. So these are some of the real-time examples of embedded system. Okay, next we are going to see about the washing machine and then its implementation. Now, washing machine is the machine. It is used to wash the various types of clothes without applying any physical efforts. So, washing machines plays a vital role because they save time and effort compared to hand washing. So, and they can clean clothes more effectively. So, they are considered essential appliances in many households. Okay, next these are some project equipments like MPLab, XIDE, PICSIMLAB and X8 compiler. We will see one by one. So MPLab XIDE is an integrated development environment for microchip microcontrollers. It is used for writing, compiling and debugging code for microchips PIC microcontrollers. And then PICSIMLAB. It is a simulation software that allows to simulate and debug PIC microcontroller based applications. And then X8 compiler, it is a C compiler. It is used for microchips PIC microcontrollers and it is a part of the MPLab XE compilers, and it is specifically designed to compile a C code for PIC microcontrollers. So next we are going to see about PIC16F877A microcontroller. So these are some specifications of this microcontroller, like PIC16F877A is a 40-pin microcontroller and it is using RISC architecture, that is reduced instruction set computer, and then it has 5 ports starting from port A to port E. And then it uses flash memory technology so that it can be write arrays as many times as possible, and then it has a smaller 35 instruction set, and then it can operate up to 20 MHz frequency. Then the operating voltage is between 4.2 volts to 5.5 volts. So next, apart from the specification, there are some main features in PIC16F877A microcontroller like timers, interrupts and EEPROM and watchdog timer. So now the timers, basically timers are used to generate the delays. In this microcontroller there are 3 types of timers like timer 0, timer 1 and timer 2. It can be used either timer or counter mode. Counters are used to count the external events. And then interrupts, basically interrupts is the highest priority task. There are 8 types of interrupts like external interrupts, timer interrupts, and then port state change interrupts, and then UART interrupts, then I2C interrupts, and then pulse width modulation interrupts. So next, EEPROM, that is electrically erasable programmable read-only memory. So basically it is a non-volatile memory which is used to store the data permanently. Even the microcontroller is switched off, the data will be remain same. And then watchdog timer. So watchdog timer is used to wake up the device from the sleep mode, and it is also used to generate the watchdog timer reset. So these are some main features in this microcontroller. So next we will see how to implement the automatic washing machine by using PICSIMLAB. So this is the PICSIMLAB software. Here we can see lot of peripherals like microcontroller, LCD, fans and switches, buzzers and LEDs. So first we have to set the mode of the LCD like a 16x4 or 16x2. I am setting 16x2 as a LCD mode, and then I am setting the frequency as 20. So next I am going to select the types of board. So I am going to select the board as PICGenius. Okay, and then we have to select the type of microcontroller. Okay, so next we have to load the hex file format which is compiled in MPLab XID software. Okay, and after uploading the file we have to press the key file to power on the washing machine. So this is switch 1, switch 2, switch 3, and switch 4 and switch 5. Okay, now I am pressing switch 5. So these are the some washing programs like daily, heavy and delicates. To navigate the programs, we have to long press switch 4. Okay, so now I want to set as a daily mode. So again I am long pressing switch 4, and then next we have to select the water level. I am going to select as auto level. So again I am pressing switch 4, and then if we want to navigate other things, we have to long press switch 4. Okay, now the water level is set, and then if we want to start the process, we have to press switch 5. So I am pressing switch 5. Now the fan is turned on and timer is set. Okay, so if we want to pause, we have to press switch 6. Okay, so after that I am pressing switch 5. So again the fan is turned on. So next, if we want to open the door, we have to press switch 1. So basically, while opening the door in the washing machine, the other peripherals like buzzers and timers should be in off mode. So by pressing switch 1, we can open the door. So finally the process is completed. So it shows remove the clothes. So this is the final output. After completing all the process, the LCD will display like process is completed and remove the clothes. So that's all about the implementation of automatic washing machine in PICSIMLAB software. So finally the washing machine simulation is done based on the knowledge I have gained during the internship period by using PICSIMLAB, and it offers the hands-on experience, and by this project it is clear how the embedded systems is used in real-time applications. Thank you all.